We've all been there. You paste a massive document into an AI chat, add a long, rambling instruction, and wait for brilliance. Instead, the AI gives you an incoherent mess. The paper piles up, and it slides right off the desk. That happens because we tend to treat AI like a magic box. We assume it reads and understands a 50-page document the exact same way a human does. But an AI doesn't have a human brain. It operates under strict mechanical limits. It has a ceiling on its memory capacity, a cap on its processing speed, and a very real, very measurable financial cost for every action it takes. At the center of all those limits is the true currency of artificial intelligence. They are called tokens, and they are the invisible, finite units that actually power a model's ability to process language. Failing to understand and manage this invisible token currency is exactly why bots hallucinate fake answers and why automated workflows burn through money. Human language is aggressively unruly. We use slang, emojis, sentence fragments, and complicated lines of code. To a machine, this is chaos. To make sense of it, the system chops that chaos down into tokens. A token is a standardized, numeric piece of language. But here is the catch. One token does not automatically equal one human word. Take a simple word like apple. Tokenizers read that as one single token. But an unusual word like ultra-personalization fractures into smaller, known chunks: ultra, personal, and isization. Punctuation takes up space too. Type hey hey, and the AI mathematically accounts for every single exclamation mark. The AI chops everything into units, converts them into numbers, analyzes relationships between them, and predicts the next logical token. Tokenization is the mandatory translation layer. It takes all of our emotional, typo-filled human texture and turns it into calculable machine math. Because tokens are math, they require computing power. This means every AI model has a strict limit on its working space. We call this the context window. It's the maximum number of tokens an AI can hold simultaneously. When full, things drop out. But your prompt, background documents, system rules, and the final generated answer must all fit within this exact same limit. Consider an online furniture retailer. To automate customer support, a manager built an AI assistant. But every time a customer complained, the system fed the bot an entire returns handbook and the customer's complete multi-page chat history. That strategy stuffed the context window with thousands of irrelevant tokens. The rules about refunding a lamp were crowding out the actual ticket about a broken desk. Overwhelmed, the bot lost focus. It started inventing fake delivery dates, promising unauthorized refunds, and racking up massive processing fees every time it ran. An overflowing context window directly causes catastrophic memory loss, logic errors, and exploding operational costs. Too much paper on the desk, and the most important details slide right over the edge. The manager didn't fix this by paying for a more expensive, powerful AI model. Instead, they completely redesigned the workflow to filter the tokens. They swapped out the full chat history for a tight, factual summary. And rather than dumping the entire handbook, they supplied only the single policy section relevant to that specific ticket. This chart shows the immediate impact. By filtering out the noise, the token load plummeted from 1,900 input tokens per ticket down to just 1,100. That is a 42% reduction in sheer volume. As a result, the AI drafted responses faster. It stopped hallucinating incorrect facts entirely, and it slashed computing costs across the entire support department. You can apply this exact same logic to your own daily work through token-aware prompting. First, state your tasks immediately at the top of your prompt. Second, remove the conversational filler. You don't need to politely introduce yourself to the machine. And third, use strict structural formats like bullet points and headings to organize your requirements. But the most powerful efficiency tactic of all is giving negative constraints. Explicitly telling the AI to ignore repeated boilerplate text prevents the model from spending its attention and your token budget on useless information. Mastering AI requires abandoning the illusion that you are talking to a human reader. When you actively manage the model's finite token workspace, you stop crossing your fingers and start actually directing the machine.